Okay, so I'm gonna try another mock assessment this week, and this time I'm trying a new setup for recording. I'm trying to, I don't know, get to the modern world and try to use OBS and a little bit better audio setup this last time. And also last time I think I probably went through some of the problems a little bit fast and without maybe doing a lot of good programming practice or also explanation. So this time maybe I'll try to do it a little bit slower instead of trying to rush through it. So let's see what happens. Start. Up to 4 questions or same thing, 2 hours to complete. Let's try it. All right. There are a bunch of courses, num course to take, label from 0 to num courses. Uh, and then what else? Uh, you're given an array of prerequisites where prerequisites is AI, BI, and you must take BI before you can take AI. Okay. Return true if you can finish all the courses, otherwise return false. There are total of 2 courses to take, and then prerequisites is list. Okay, so basically, the only time you cannot do this, right, so there's a graph. It doesn't ask you what is the order in which you do it. It just says yes or no. And so you have graph of prerequisite, and basically we're asking in this is a directed graph. You have a directed graph. Do you have a cycle? I think that's pretty much all we're talking about. So how big is it? 2,000 courses up to. Okay, so basically you have a adjacency list, but the adjacency list is backwards. Or we can just pretend that all the edges are forward anyway, because we're just looking for cycle. We don't really care if the edges go backward for the problem statement or not. We just want to know if there's a cycle. So the typical thing that you do is depth first search. Um, so what do I do? Right, so oh, how do I, can I draw something? No. Okay, let's see if I can draw something here. Um, so if I have some node like this, right? So I start DFS from somewhere and I see if I can end up at a place that I come back to. But because it's a directed graph, I have to be a little bit careful when I go like this. Maybe eventually I mark these things as visited, and then I would have something like this. So I would point to a thing that is visited, but it's not a cycle. So the typical thing to do in DFS in the directed graph is that when you enter, so each node has 3 states. You have unvisited, so you've never seen it before. You have visited, which means that you have finished visiting. So for example, here I've gone down this path, and then there are no more descendants. So I'm out. I back up. And then the third ring is in progress. So for example, if I come down here, I start BFS from here. This is in progress, in progress, in progress, and then I'm done. So this becomes visited, I back up, this becomes visited. Back up here, I'm not done, so I come down here, and this is in progress, and this is visited, so I don't go there, but I also don't have a cycle. But if at some point I ever see an in progress, if I point to a node that's in progress, then that means I have a cycle. So I need to have 3 states in my DFS. What else? Where do I start my DFS? I can find some nodes that doesn't have a prerequisite and start from there, right? If and then start from all such places. And if I cannot find such a place, then there's no way. I think that's it. Okay, so let me erase this thing. Okay, so let me just start doing the coding. So I already have a graph, and I said that well, okay, let me just reverse the edges, because the edges are kind of backwards, right? The BI is you have to take BI first, and then you take AI. So the edge actually points from BI to AI. So what I'm going to do, the first thing I'm going to do is reverse the direction of edges. And I can do that. I can probably write a function to do that, or I can just say for auto v auto ampersand v, because I'm trying to change it. Prerequisites. Did I spell this right? Prerequisites. So each v is one edge, which has 2 elements. I guess I just swap v0 and v1. Okay, so now I have all the edges. And now I have to know which one has I want to know which one has no prerequisites. So actually I can be here. So I can have vector of int DFS starts. So this would be a vector of places I can start DFS on, and this is when I have no prerequisites. Oh, actually let's use a vector boolean. So at the beginning, all of them can start. But then here, when I see that I have an edge from v0 to v1, because I swap it now, so v1 cannot start. Okay. And then I'm going to ask if count, so this is the STL function count, I'm going to count how many places I can start. Okay, so I can start in no places. That means everybody, so that I can't really start any classes. Okay. And now I can do for each one I can do my cycle detection. I guess I can do cycle detection, or I can just do the usual DFS with just two states, visited and visited. Don't visit anything that you have already visited before. And then at the end, ask if I marked everything. So the two different approaches, I can do psychodetection, or I can just see if I mark everything. Which way do I do it? I guess it's easier to do that, just mark everything. So vector bool visited. So I'm just going to do that. Nothing is visited for auto for int I equal to 0, I less than num courses, I plus plus if DFS start I. So if you can start the DFS here, I do the DFS from this node. I need to pass in, of course, the prerequisite, the graph. The node and then the visited. So that will mark whether I visited everything. And then I just need to know if visited is everything. So return count visited at begin count how many trues there are has to be exactly the same as num courses. Okay, so now I need to write a DFS function. What am I taking? The prerequisites. I'm not going to change that, so I can fix it. Start at the node V. Like this. And, well, I guess just for good practice, because they use this coding convention with the ampersand there, I should follow that. Okay, sorry, let's just get a little cough drop here. Okay, so DFS. Now, the different ways you can write DFS. So two different ways. You can do it recursively, or you can use your own stack. DFS, if you use your own stack. If you do it recursively, you have to worry about going too deep in the recursion and have a stack overflow. But in this case, there are only 2,000 courses, so you're probably okay. So we're just gonna use the recursive way. So I'm here. First thing I do is visit v equals to true. And then I'm going to go through all the So the problem is that the graph is in a very unfriendly manner. Right? There's no easy way for me to figure out uh, who are all the neighbors of V, because it's just a list of unsorted pairs. So maybe what I do instead of this, it's a graph. And I would need to build a graph with an adjacency list. And so here, instead of sorting like this, I would just say graph square v1 dot push back v0, but now because I'm not swapping, this better be v0. I don't need to do anything else. I just need to send the graph in here instead. And now I have a graph, then I can say for auto w graph v, so these are all my neighbors, if not visited w, because we don't want to visit again, I recursively go dfs graph w and visit it. And that's it. So that's a relatively simple and quick implementation of DFS. Oh, there's only 3 questions. I just noticed. Last time we had 4 questions, so maybe the 3 questions are harder. I don't know. Okay, let's give it a try. Okay, that's one. Use example test cases. True and false. So maybe one more case. Well, actually, we should really do more cases. But let's have the situations where 1, 2, 3. Let's have 4 courses. Okay, the edges are backwards, so 1, 0, 2, 1, and then 0, no, 3, 0, and then 1, 3. So what is this graph looking like? It's like and we should be able to say that it's true. I'll have to turn off this. Okay. True, okay. But if I have another, no, let's say a 5 that goes back to here, then it just say no. Okay, wait. Oh yeah, that's right, because I wouldn't be able to start my DFS. So, aha, you see this is wrong, whatever I did. My original approach is right, but I switch midway and now I got a wrong algorithm, because if I have something like this, I would start the DFS here, it'll come, it will mark everything, it will come back here and it won't, and then it would just mark everything and say yes, that is good. I have to go back to my original idea of marking marking things in 3 states. Okay, so I guess the lesson here is, if you have something that works, if you know that something is correct before because you thought it through, why the hell am I switching midway because I somehow feel like I have an easier solution? And that's a horrible idea. Okay, so what do I want to do? We'll change it to has cycle, return boolean, and this time we'll have state. Let's call it state. So we said there's 3 states, visited. Those are the 3 states. Okay. So at the beginning, this visited. Where do I have visited? Okay, so this has to be changed to state, state unvisited. So anyway, the point, I guess, the 2 points. The first point is if you had some good, if you have a good idea that you thought through, um, you should not change it midway because you feel like all of a sudden you have a way to make it better. Um, and then the other way, the other thing is just because it works on a sample input and even the one simple case I choose, I have to constantly think about how I can break my code. Uh, and then that's how I discover that there's a problem. Okay, so if I can start in the DFS and it has a cycle, then I want to return uh, false. Otherwise, I already know that there's some place I can start. I start at all the different places and it has no cycle, so I can return true. Okay, so what are we gonna do? So we'll change it like it in progress. The first time I code has cycle, it can on the top level. I can only call it when a DFS start is true, so there's no way I can be visited already because there's nothing that can point to it. Okay, so visit is in progress for not visited state for all the neighbors if state W, okay, so that's three choices. If state of W it's equals to unvisited, then we visit it. Else if state W is equal to, I guess you can use a switch, although in the case of, I guess we switch state of W. We prefer switches because these are constant. Case unvisited, then DFS, no, not, uh, wait, okay. Now we have to be a little bit careful because we want, actually it has cycle graph W state, and if that returns true, I want to return true. If I can find a cycle anywhere. If not, then I don't do anything because there could be another branch. Case in progress, return true because that's, and then that's it. I don't need the visited case because in the visited case I don't do anything. So if I recursively find the next node and then somewhere down the line it says that I have a cycle, I return true. If I found it in progress already, I return true. And then when I'm done, just before I exit, I mark B to be visited, no more children, and return false. Okay, that's okay. True, false, true. Okay, so and then let's do the one more case. So this is the same graph, but then I have one node in front of me. So 0, 4. So that's the node that I add at the top. And that's supposed to be, wait, oh yeah, I want actually one more edge that goes backwards. Um, 1 3 to 1, and then I want one that goes from 3 to 0, or 0 to 3. Okay, that should return false. Okay, now I think I'm more comfortable. Uh-oh. Input, on this input I get the wrong answer. Okay, I need to draw this graph and find out why. There are 20 nodes. Okay, so this is kind of complicated. 10 goes to 0, and it's kind of nothing involves 10 and 0. Okay, 18 goes to, oh, 5 goes to 5. Is that? Okay, so what did I do here? Okay, so maybe I wasn't, I think that's the problem. Did I? It doesn't say that AI and BI cannot be the same. So the self loop, so that's the one thing that I missed. Okay, is that the only problem? That's a next question. Okay, so 18 to 3, 5, 5, 11 to 6, 11, 14 to 11, 1 to 13, 1 to 15, 4 to 17. Okay, so there's a bunch of things like that. And the answer is true, except for that 5, 5 there. So why don't I take this input, put it in here, and get rid of the 5, 5. Yeah, of course. So why does it fail? Because 5, it's not a place that I can start. And you will never try to find Psycho there. You will never try to start there because it, And actually, generally speaking, okay, so I have a deeper bug than that, to be honest. Even if I have, if this is not a 5 like this, if I have something like this, then this would never get checked because DFS starts. It's not right. So at the end, I still have to check. Oops. I still have to check whether all the things are visited. So count begin state visited equals to num courses. So here's a Psycho. This is the code I had before. If I run it, it will tell me it's okay. It's true, even though it's false. And now I do it right. Well, that was unfortunate, but I do want to show you how we tackle things when things don't go right, how we analyze the situation. So I wish I could say that was intentional, but it's not. So let's go to the next one. Oh, more courses. They're Wait, what is this? Is that the same problem? No. The total number of num courses you have to take, label them, blah, blah, blah. Okay, so this is same input format. We turn the order in. You should take to finish all the courses. Okay, so this is topological sort. So it's the same problem, but this time instead of true or false, you have to also give the order. Um, okay, so what should I do? Let me just, I think I can read. So the two ways you can, there are many ways you can do this topological sort. I can start from scratch, or I can hack, well, I shouldn't use the word hack. I can modify the previous solution to not just say yes or no, but also build the answer. Wait, what did I do? Did I copy right? So I guess I'm just gonna try to modify this. So okay. So clearly I have to say this will tell me, whether the answer is good or bad. Return an empty array. So um, this is an empty array. I have not done anything, so um, that would make sure it counts. This is not. So this order that I somehow end up building. So my S cycle would also build this order. I don't I don't know if this is the best way to do it, because if I were to write it from scratch without the other problem, I might have I probably wrote it differently. But anyway, vector of int order. Okay, so what do? We have a graph, and we're doing DFS, and then maybe this goes there, and this goes here, and so on. So we're going. So this is 0, 1, 2, 3, 4. When we're going to do DFS, we're going to go 0, 1, 2, 3, and then this is back out. So we push this 3 in, we back out, we back out, then we come this way, and then we back out, and then we finally back out of here. So the typical thing that you do is you do a DFS and you push it into the order um, as you're backing out. And then at the end, you get the list that is reverse order. So this is, okay, so when you have a cycle, we return true, so we don't care. It's when we return false that we have to worry about. So we're gonna push, oh wait, this has to be passed by reference. Order dot push back v, just so that we don't push back too, we don't reallocate too many times. We just allocate all in one go. That would be more efficient. And then before we return, we got to reverse the order. Okay, so this is standard topological sort. There are a couple of ways you can do this. Another way you can do this is to push all the things that you can start the DFS on, and then you take that course, I guess, over that course, and then update all the neighbors to see which, and then if the neighbor now has no more prerequisites left, then you push that into a queue. So it's kind of like peeling off all the things that you can take one at a time with a reference search in some way, and then you can use it. You can kind of remember which course you take in the order of this reference search. So that's the other usual method of doing it. The two standard ways of doing topological sort. But since I already did did it question one, I might as well just kind of use this. If I wrote it from scratch, I'd probably write it the other way because there's no recursion. But anyway, let's run the code. Oh, compile error. Oh my, okay, I forgot to update this. But that's a problem with cut and paste coding. Sometimes you forget to change everything. Okay, so this one is clear. Can I get the test cases from? Oh, I don't have the test cases typed. Okay, so you run example test cases. There's 3 examples. Okay. Ah, okay. I forgot about that one. So what do I do there? So they're actually kind of nice that they give me this test case. So at this point, it's very tempting just to say, if number of courses is 1 and the prerequisite is empty, just do that. But we need to think about the bigger picture. Okay, are we missing any? Is this a just this one special case, or is it a symptom of a bigger problem that we haven't considered? So generally speaking, if there are no prerequisites, you can take them all. Wait, no, I do produce the right output. I was thinking, why do I was looking at it wrong because I look at it, the input. Okay, no, I do get it right because I will do the DFS. Okay, so it's not that I didn't consider it, it just works. I was just looking at the wrong output. Um, yeah, as I was thinking about why wouldn't it work? Okay, Okay, so I'm submitting. Success. Okay. Third question. Okay, a tree problem. So it's as usual. Root has a value and then recursively pointed to the left and pointed to the right. And you have this kind of constructors. Okay. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in a sequence has an edge connecting them. Node can only appear in a sequence at most once. Note that the path does not need to pass through the root. Path sum of a path is the sum of the nodes values in the path. We turn the maximum of a path maximum path sum of any non-empty path. Okay. Nodes in the range is between 1 and 30,000. Node values between 1,000 and negative 1,000. So the first thing is, well, I guess in this problem, in LeetCode, they actually give you the prototype, so you don't have to think about is the result going to fit in a 32-bit integer, because they pretty much told you. Otherwise, they would use a different data type for the prototype of the function you're supposed to write, but it's still good to think about, right? 30,000 times 1,000 at most. That's still well within the 32-bit integers. Okay, so you want to find the maximum. Okay, so with any tree problem, we do this usual thing, right? If it is an empty tree, what is the answer? Otherwise, what do we do? If the empty tree, the answer is 0. That's easy. Okay, so what about non-empty tree? Okay, so basically, you have two possibilities. The maximum sum, three possibilities. The maximum sum could be the maximum path completely within here, the left subtree. You can have maximum path completely within the right subtree, or it has to involve the root, but then you have to go down somehow this way and that way. So the root plus the best on the left and the best on the right, but it's a different kind of best because you can only go down and not do this U thing. Otherwise, not cut to somewhere in the root. Okay, so what does that mean? That means that we probably have to write two recursive algorithms. One that look for sort of the best path without any branching, and then the best path with one single branching, which is actually the max path sum. So that's so what we're gonna do. Okay. Int max, what do I want to call it? Uh, Single path or max. Let's cut root line sum. So what does that mean? It means it starts from the roots and it follows a single line. Okay, so um, you have a tree, and we want to start from the root. We guarantee that the root has to be used, right? We're not allowed to not use the root, or we just say we don't allow it at all. It's possible, we just don't do it. And then it goes this way or that way. So first of all, always if root is null pointer, return 0. Okay, so if empty tree, there's nothing. Otherwise, left is equals to the best, it's root val plus max root line sum root arrow left. So these are either you go left or you go right. So I want to take the maximum of 2, but I also, if both sides of best is negative, I would just say the best for this subtree, or for this tree, the best thing is just not to choose anything. Okay. Now I do have to worry about this non-empty path business, but for now, I'm going to say return the maximum of 0 and the maximum of left and right. So somehow going either way, the best way is a negative number as well as just return the empty tree, return the empty path. Okay, so this possibly can return the empty path. I have to remember that. Okay, so now max path sum. What can it be? Again, if root it's empty, then I got to return 0. There's nothing I can do. The tree has to be non-empty, right? The number of nodes is at least 1. Okay, otherwise the answer could be empty. Okay, so, but I know that it starts with a non-empty tree. Okay, so now I want to know if I just go either to the left or to the right, what is the maximum sum? Okay. Or it could be the maximum path completely to the left or completely to the right. I want to take the maximum of the 3, and if I decided if the maximum is negative, I want to return 0, meaning that I take the empty tree, empty path. But of course we have to worry about this. Oh wait, we hang on. Wait, I forgot about this. Okay, so maximum root like this, but I can also actually this is not right. It's root val plus right, because I go through the roots basically. So this is the best way to go through the roots. And I want to return the best. Okay, so I don't want to call it maximum path sum now. No, so maximum path sum, the way that I have it, possibly can return an empty one. So I want to call it max path sum helper, I guess you call it. I said I was going to follow the same coding convention here. And I want this. Okay, so max path sum helper. And then I want to return the maximum of the three things. But if it's negative, I want to return 0. Okay. So now, if I call max path sum helper, it will return the best one. But it could return an empty tree, empty path. So when is that a problem? The problem is if all the nodes are negative. If all the nodes are negative, then I will just keep choosing nothing. And I will return 0, which is the sum of an empty path. So in the case when everything is negative, then I want to take this biggest negative number. So I need to know max value in the whole tree. If not roots. So negative infinity is basically the max value of the tree. Otherwise, return the maximum of root value and the maximum of max val root arrow left and root max val root arrow right. Okay, so what just happened? This will return the maximum value of the entire tree. And so I'm going to call if max val of the tree is less than 0. Okay, int maximum equals a max val of root. If maximum is less than 0, then I'm just going to return the maximum. So if everything is negative, then the best path is a single node containing the biggest number, which is still negative. Otherwise, return max path sum helper of root. Okay, let's see what happens. Okay, 1, 2, 3, the answer is 6. Okay, use example test cases. There are only 2 cases. Okay, run. It's 6 and 42. Okay. Do we believe this? What if everything is negative? So let's just make it minus 9, minus 20, minus 15, minus 7. -7. Okay, that's what we want. Oh, actually success. That is that one. All right, so I guess that's it. Let's see what happens. So, uh, looking back, let's see what happened. Um, binary tree maximum path sum is supposed to be hard. I guess I can see why, because there are like multiple little test tricky cases, right? That's you have the recursive thing. Yeah, not so great because I screwed up. I think because I have an incorrect answer. That's probably and then well also because I think time spent it's also a factor, and I did probably spend a little bit more time explaining than if I was just trying to uh, go as fast as possible. But anyway, that doesn't really matter. So looking back, um, what do I want to say? Can I actually go back to that? Okay, so this one went pretty straightforward, but I can see why it's hard because there is the problem of the non-empty path, and then so there's the you have to deal with that because they're negative numbers. There is the problem of do you go do you look for the answer completely in the left side, completely in the right side, or go through the roots? But then if you go through the roots, recursively the subproblems on the left and right are somewhat different, so I have to write a separate thing. Um, course schedule 2, I don't remember any problems because I basically just took course schedule 1 and then add a few things. Oh yeah, the problem was that I run the test case 3 and then I thought I got it wrong, but I just didn't read the output because my window was too small and didn't see it. Okay, so there's nothing to say here. It's a standard topological sort. Um, this one was where I had trouble with. I first thought about, well, how should I put it? First, I thought about this in progress unvisited, not because I'm you know, ingenious and then know about and then can invent this thing on the fly, but because I've seen it a million times. That's a pretty standard thing that we teach about DFS and directed graphs. Um, and then at some point, I decided that I can take a shortcut because I can just see how many times I visited something, and then that was wrong. And then I was moved back to here, but I got it wrong again because it turns out that I do have to think about this. I just have to think about both of them at the same time. Um, so uh, that's what happened there. Okay. Anyway, um, so last time it was much better because I didn't have any wrong submissions, and this time was worse. But anyway, and then it was slower because this time first I have the incorrect submission, but I also spent a little bit more time explaining that I normally wouldn't be doing. But if this is like a normal interview, you do want to explain. Okay, so anyway, I guess just stop here, and if people like it, I'll do another one next week.